let's say you wanted to get a bunch of numbers from the user and then calculate, let's say, the mode and the mean. So the mean is an average. So this is really just the sum divided by the number of values. The mode is the most commonly occurring value. So let's say we want to get, from the users and be able to do these. So we could, for the mean, just keep a running total of the sum and a running total of how many values there are, and then return the sum divided by the values. But for the mode, we really need to collect these in a list so that we can then take a look at all the values and find the most commonly occurring value. So we need to be able to take from the user and fill up a list with values. So we're going to need a loop that lets them enter values until they want to quit. Let's see. What else do we need? Where we need to figure out how many functions we want. So we're definitely going to have a main function. We could have a helper function that manages to get the list from the user. We could have a helper function that determines the mode, and we could have a helper function that determines the mean, as well as a welcome helper function. So now that we kind of have some ideas about how we want to get started, let's go ahead and start coding. All right, so let's set up our structure here. So we know we want to have a helper function that just sort of prints some kind of welcome for the user. And I forgot the def keyword. Got to define our function. We said that we wanted to have a function that is going to fill a list with user values. And we can call this def fill list. And we don't need to send anything to that. It's just going to get a list of values from the user and then return that. We're going to have a helper function that is going to get the mode of a list of values, and we'll call this def, maybe we'll call it return mode, and this is going to take a list. And we also are going to have get the mean, also known as the average, of a list of values. And we'll call this return mean. And it also needs to take a list. And then, of course, we're going to have our main function. And we'll make our lives easier by just throwing in a call to main at the end. So let's go ahead and run this and make sure we don't have any syntax errors. Call this. And we're good. All right, so we can get started. We can either do our main function first, or we can, do our helper functions. Doesn't really matter what order we do them in. Let's just go ahead and do our helper functions first. So we'll just say print this program lets you enter a number, enter values, and calculates the mode and mean of those values. All right, so we're just going to tell the users what we're going to do with our program. And that's really all we need for our print welcome. So let's make sure it works. All right, so that works. So now the next step is to get a list. So we're going to need a while loop. So let's say that so we have a little bit of an issue here. So the problem is that we want to let the user enter any value. So, you know, zero, negative numbers. So we want the user to be able to quit when they're finished entering the numbers. So we need to structure our while loop such that it checks for the quit while the data we've taken from the user is still a string. And then, of course, we have to cast that to a float or integer in order to save it into the list to be able to actually do anything with that number. So let's see how we can do this. So let's just start out by getting some input from the user. So enter a value, enter Q to quit. All right, and we're going to have to really think about how we want to structure this so that the logic will work out. So let's start out with while user dot lower does not equal a lowercase quit. Then we're going to go ahead and enter our loop. And then we've got to have our update. See, so we're going to make sure our loop works. So they should be able to quit. So let's check this. We're just going to print in the loop, and it looks like I might have some spacing off here, so let me just check that. So let's make sure that we can quit appropriately here. So let's just call fill list and make sure that our loop is going to allow us to quit. So here we've got, we're just entering some values. We're in the loop. All right. And so if we enter a Q, we're going to quit. All right, so our loop works. We got to double check one more thing. We wanted to allow them to also enter a capital Q. That will work. All right, so our loop is working. Our loop will let them quit when they enter lowercase or capital Q. So now we have to think about what we're going to do with this value. So if it's not a number, we don't want it. We don't want to add it into our list. So let's look at this first. Let's let them do floats. Okay, so what we're going to want to do is we're going to want to check each of these strings to make sure that it meets the requirements for a either an integer or a float before we add it to the list. So let's do this. So we're going to say is value is going to be equal to true. All right. Then I'm going to go ahead and I'm going to loop through my user input. So for I in range from 0 to the length of UI, I'm going to loop through it. And I'm going to say, let's not do true. Let's actually set it to 0. We're going to call this, let's call this digit desc count. So what I'm going to do is I'm actually going to look at each of my values inside of my string. Let's take a look at this a little bit differently. All right. So let's look at some possible inputs here. So let's say they've entered all letters, right? Let's say they've entered this. Let's say they've entered this. Let's say they've entered this. This is okay. This is okay. This is not. This is not. So what I'm going to do is I'm going to loop through every string and I'm going to count. I'm going to look at each one and I'm going to say if it's a digit, and we can do that with the isDigit function, or we could literally check if it's a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or it is a decimal. If it's one of those, I'm going to add 1 to my count. And at the end, if this decimal digit count is equal to the length of the string, then I know that everything in that string is either a digit or a decimal. Now, there's another issue that could come up though. So if I have 3.43.3, this is not castable either. So actually really what I need to do is I need to do digit count and I need to do a decimal count, and then really I want to make sure that there's only one decimal place. So let's take a look at how we can do that. All right, so what I'm going to do is I'm going to count the digits and decimals with this, but then I'm going to go ahead and have a decimal count as well. So this has to be equal to the length of the string, and this has to only be 1. All right, so let's see how I'm going to do this. So I'm going to say if UI sub I, so if the letter that I'm looking at, the character that I'm looking at, dot is digit, so if it's a number, if it's 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, then my digit des count is going to go up by 1. Elif UI sub I, just going to keep typing in things wrong apparently, is equal to a decimal point. So in this case, we want to increment digit des count plus equals 1, and we also want to increment our decimal count plus equals 1. All right, so when I exit the loop, if digit des count is equal to the length of UI and des count is less than or equal to 1, because it's also the case if it has no decimal point, it's also fine. So as long as there was either 1 or 0 decimals, then we're going to, we need a list to put it in. So let's call this list, and we're going to make this an empty list. So the first thing we're going to do is we're going to say list.append, and then we're going to put in, we'll just go ahead and cast them all as floats, because integers, you just put a decimal on it, it's fine. So we're going to cast it as a float, and then we're going to add it to the list. All right, now we're going to let the user continue to do this as long as they want, and then as soon as they quit, as soon as we get out of this list, we're going to, or out of this loop, we're going to return our list. All right, now to make sure this works, we've got to call fill list. Actually, we can just print the call to fill list. We're eventually going to want to store it in something, but let's just start by going ahead and printing the call list. Okay, so I can do this. I'm just in the loop. I can do this. See, 3.43. 3.2.2. Let's see what else could not work. Okay, so now when we quit, what should print, we should just have this 342 and 3.43 as values in our list, and we do. So it ignored this, it ignored this, it ignored this, and when we quit, we actually quit outside of the loop. What we saved was appropriate value. So this is an appropriate value. We can add these together. This is castable. This is an appropriate value. That's castable. So what we ended out with was the numbers that we can use in our program, and we ignored everything else. So now that we have our helper function done that's going to actually fill the list for us, let's do that. So here we're going to have my list down here, and we're going to set that equal to our fill list function. So this function is actually going to fill the list up for us, and then we're going to use this list to call these other functions. So let's work on writing those. Let's do the mean first because that one's going to be the easiest. Once we get the list, we're going to do a sum. And we're going to start that at 0, and then we're going to loop through the list and add all the numbers in the list up together. So we're going to say for I in range from 0 to the length of list, sum equals, or we can do sum plus equals, use our little shortcut here, list sub I. So we're just going to add those all together. And at the end of that, we have a sum. Oh, and see, this is purple, so actually we don't want to use that. That's actually the name of a built-in function. So we'll just call this my sum, or we could call it sum1. All right, oops, let's be consistent. We don't have to spell it correctly when we're making our own variables, but we do have to be consistent when we're making our own variables. So once we get out of our loop, we have our variable with all of our values added up together. And now to get the mean, we'll say mean equals my sum, and the number of values we have is really just how many values are in the list. So we can actually just use the length of the list. We could have used a counter variable to count it up for us. There's other things we could have done, but in this case the length of the list will work for us because it's just however many are in the list. That's the number of values we added up, so that's going to be our the number of our values. So then we can return the mean. So let's test this out, and we can call this mean also if we wanted to. It's a good idea sometimes. Maybe we'll just call this MN. To use different names, it just reminds us of local and global scoping. So we're going to call the return mean function with my list. So let's run this, and we're actually going to fill up a list and get the mean. Actually, you know what? Before we do that, we actually need to print out mn, because this is only going to save it into our variable mn. We want to actually print out to see what that value holds to make sure our function is working correctly. All right, so now we're ready. Let's run. All right, so let's do 100. We'll do 50. I need to erase that in the loop. And then we'll do, let's see, so that would be 75. Let's do 100 again and 50 again. All right, so now I know the mean of this should be 75. And it is. So our mean is working, printing it out just nice. So we've finished our return mean. We had this code there that was just kind of helping us make sure that our loop worked before we added the code in. So I'm just going to comment that out so it won't show us anymore. And we could change this, enter another value, just so that the user knows we've actually made it past this first statement. So let's save this. All right, so now we've got everything working except our mode function. So to do the mode, we have to kind of think a little bit about, again, what the mode means. So if we have a list of numbers, let's say, we have, 25, make sure this is, there we go, 25, 25, 6, 7, and 9. The most frequently occurring value is 25. If I have a list, 6, 7, 7, 9, 9, the mode is really both 7 and 9. So this is going to be a little bit more difficult to determine. So we're not going to worry about this case where, to begin with, this case where there's two equally occurring values. We're just going to handle this first case first. So let's think about how we could deal with this. Well, we do have a built-in function that's called count that will tell us how many of a particular value is in a list. So we're going to give it a value, and it's going to tell us how many number of times that appears in a list. And we can use that to come up with an algorithm kind of like how finding the maximum of a number works to find the mode. So let's see what I mean. So I'm going to start out and I'm just going to set the mode to the very first element of the list. And we can't set it to 0 because, we could have negative numbers. We really want to compare all the values of the list to the other values of the list, not an outside value. So I'm just going to randomly choose the first value to set the mode equal to. Then I'm going to say for I in range and actually I could start at 1. I don't have to start at 0 because I'm already using 0 here as I set the very first element to mode. That's what I'm going to use to compare. So I don't actually have to start at 0. I can just start at 1, and then I can go to the length of list. And I could start at 0. It's fine. It's just going to compare it to itself, and it's just going to keep the one, that it has. All right. So now I'm going to say that if the mode that's currently in there, well, actually, I want to count it. So if I say list dot count of the mode. So I'm going to take whatever is in the very first index of the list, and I'm going to count how many of those there are in the list. So, let's say in that first example, if the first value is 25, then it sends it 25, and it tells me there's 2 of these. So in this case, I'm just going to start out and say, okay, so if the count of the mode happens to be less than list dot count of list sub I, so the current or the next element in the list, the current one in the loop. So I'm looking at whatever the current mode is, the count of the current value we've stored in mode, and I'm going to compare that to the count of the element that we're looking at. And if the count of the element that we're looking at happens to be greater, then I'm going to say instead I want to go ahead and set my mode equal to whatever is in there instead. So, if I counted, okay, so, this is maybe, let's say we started with this list. Let's say we started with maybe, 6, 25, 7, 25, 9. So I put 6 into mode, and I want to count those. So I say list.count how many 6s there are. There's 1. So in the loop, now I'm looking at list sub I. So the first time I'm looking at list sub 1, which happens to be 25. And I'm going to compare that, the count of this in the list. So if I say, what is the count of list 1 sub I? So what's the count of 25 in this list? Well, that happens to be 2. So in this case, that's greater. 2 is greater than 1. So it's actually going to store that into my mode variable. When I get through all of this, the mode should store the value that has the highest count. And you can trace that to see how that works. And then I'm actually going to return that. I'm going to return the mode. So down here, if I want to go ahead and call, so we'll just say MD is equal to return mode with my list, and then I want to print MD. Here we go. All right, so if I do that and I say 6, 25, 5, 25, 9, 25, and then I quit, here's my mean that's calculated, and then my mode is 25. That is the most frequently occurring value. So this works as long as there's only one most frequently occurring value. So we created a function that would work if only one value was the most frequent, but in cases where we have something like, we've got maybe 9 and 9, so now 9 is in there twice. Let me put commas so it makes this a little bit more clear, and 25 is twice. Well, then really the mode is both of these. 25 occurred twice and 9 occurred twice. And then the scientist can decide, do you want to average the two modes to get another mode, or there's some other ways to handle it. But we just want our program to be able to handle returning all the numbers that occur the most frequently. So if you have more than one value that occurs the same number of times, we need to be able to return all of those, not just one of those. So in this case, this will only return really the first one it finds. Or if we put in equals here, it would return the last one it finds. So we need to modify to change that. So we're still going to start out with our mode equal to list sub 0. And actually, we're going to use most of this code. So we can go ahead and bring this code down. We can use it, we just need to modify it. So we're going to end out with more than one mode potentially. Now we may only end out with one, but we could end out with more than one. So what we're going to do is we're going to store those in a list. So let's create an empty list that what we'll do is when we find a mode that we're going to actually store it in the list for us. So here we go. So we're going to be looping through the list, we're comparing it, and we're going to add this. We're still going to say if the list count of that mode is less than or greater than the mode that we currently found, we're going to go ahead and set this mode equal to that list item. So we're going to add another piece here though. So now we're going to say that if our current mode, whatever the current mode, is not in our mode list, then we want to add it to the mode list. So we're going to say mode list dot append that mode, and then instead of returning the mode, we're going to return the whole mode list. So that's really all the changes that we need to make to our program. So let's see how it works. So let's try it. So now let's say we've got 25 and then we've got 6 and then we've got 25 again, and then maybe there's 9 and then maybe there's 8 and now there's 6. So now there's two modes. 25 occurs twice and 6 occurs twice. So if we quit, so we have a problem here. So, I know what we need to do to fix it. It's not just if it's less, it's if it's less or equal to, because in this case, it will be equal to because 25 has a count of 2 and 6 has a count of 2. So this should fix our program now. All right, let's try it again. So we've got 25 and we've got 6 and we've got 7 and 3 and then 25 again and 6 again, and then when we quit we should get 6 and 25 now appear in our mode list. So that's what we want. It's always good to test for different things. So let's make sure this works if the first value is not one of the ones we're looking for. So let's say we say 25 and then 3 and then 25 and then 9 and then quit. Now we should have 3 and 25. So this handles, now it's going to return our new version 2, and I had to of course fix down here that I'm not using my return mode anymore. I'm returning the new and improved mode, version 2. I left this as version 1 and I added that it only works if one value is the most frequent, and so now our new and improved version actually returns us more than one mode. So here's our nice little program that utilizes lists in a number of different ways, and hopefully this starts to give you an idea of how incredibly useful lists are. We can use them for lots of different things. It makes our programs much more versatile and really expands what we can do. So get practicing with lists, and happy programming.